So what we're going to look at today is still the same type of problem. It's just that if we didn't have access to graphing technology, how would we solve them? So I'm going to show you two different methods today of how we're going to solve them without graphing the solution. So first one is called the simplex table method. And what you're going to do is I'm going to do the graphing part last just to show you how the algebra goes back to the graphing. So what we're actually going to do is these two steps aren't really part of this table method. You really start down here. So we're going to start creating slack variables. So we're going to change the inequalities into equations. We're then going to create a table. And then from that table, we'll be able to determine the max or min, depending on what it is that we are looking for. So I'm going to kind of not go perfectly in order here, so just kind of bear with me. It says, consider the following linear programming problem. We want to maximize the profit 12x1 plus 10x2, subject to the inequalities. 5x1 plus 3x2 is less than or equal to 15. x1 plus x2 is less than or equal to 4. And then x1 and x2 are both positive, so they're greater than or equal to 0. So we're going to skip to part D first. And then I'm going to go back and show you how this connects to the graphing part. So what we have to do is we have to add what are called slack variables into our inequalities so that we can turn them into an equation. So I'm going to take the first equation, 5x1 plus 3x2, and I'm going to add what's called a slack variable. So plus s1, and I'm going to change it to equals 15. The second equation is x1 plus x2. I'm going to add my second slack variable and set it equal to 4. So because I've changed it from an inequality to an equation, I've added what is called a slack variable. It's basically to catch up whatever whatever I plug in here. If I'm short, I can add it with the slack variable. Okay. Once we have our equations, we have to set up our table. And you'll see they did the first row for us. So I'm going to explain how you set up your table from your information here. 2 variables, 2 slack variables. And what you're going to do all the way through your table is pair zeros. So I'm going to put x1 as a 0 with x2, x1 with a 0 with s1, the next line x1 with s2. So I'm going to make all the pairs of zeros. So x1 and x2, x1, s1, x1, s2. So x1's been paired with everything. So now I need to pair x2 with s1. Then I need to pair x2 with s2. And then I need to pair s1 with s2. The zeros are going to be the same every time you're working with 2 variables like this. So your default table would be set up the same. Now, the goal is we're doing this algebraically. We don't have access to a graphing calculator to find our corner points. Okay. When we did it on the graphing calculator, we got all the points. It was really easy. We would have put those points in the table and then solve for P. So we're going to do it algebraically here, knowing that our equations are 5x1 plus 3x2 plus slack 1 equals 15, and x1 plus x2 plus slack 2 equals 4. So you can see here, if I make x1 0 and x2 0, these are gone, and I'm just left with slack 1 equals 15. That's where they got that from. And slack 2 equals 4. Plugged in, what color was I on? Blue? 0 for x1, 0 for x2. That makes 0 plus 0 plus slack 1 equals 15. So slack 1 is 15, and then they put that answer there. x1 and x2 are 0, so 0 plus 0 plus slack 2 equals 4. Slack 2 equals 4. Two of our variables are going to be zeros that we're going to plug in to solve for the other two. Okay, so I'm going to make x1 and s1 0. So I'm going to start with that top equation. So 5x1, so that's 0 for the first one, plus 3x2s plus s1 is 0 equals 15. 3 times what is 15? 5. Okay, so x2 is 5. So now I go to the second equation and figure out my missing variable slack 2. So x1 is 0, 0 plus x2 is 5, plus s2 equals 4. To solve for s2, I got to subtract 5. So s2 is -1. Next pair, we'll go purple. So we're going to make x1 0 and s2 0. So I'm going to start with that second equation first. So x1 is 0 plus x2 plus 0 equals 4. So x2 is 4. And then I can plug that back into the first one. x1 is 0. So 0 plus 3 times 4 plus s1 equals 15. So is that 12 plus s1 equals 15? What do I need to add to 12 to make it to be 15? 3. Okay. All right, next pair. What color haven't I used yet? What color is this one? Oh, dark blue. Okay. We're going to do x2 is 0 and s1 is 0. So this one's 0, this one's 0. Oh, let's see. Top equation. So 5x1 plus zeros. So zeros, 5x1 equals 15. X1 is 3. Okay, then we check our second equation. 3 plus 0 plus s2 equals 4. So that would be 3 plus 1 gives me 4. All right, we got 2 more pairs to check. So x2 with s2. So I'm going to use a second equation because that one has s2 in it. So let's see, x2 is 0. So x1 plus 0 equals 4. So x1 is 4. And then if I plug that back in the top one, 5 times 4 plus 0 plus s1 equals 15. So 20 plus s1 equals 15. And then if I solve for s1, subtract 20, s1 is -5. All right, the last one is going to be the most algebra we do. So we're going to get rid of the slacks completely. We have 5x1 plus 3x2 equals 15. And x1 plus x2 equals 4. And I'll use either elimination or substitution. I always like elimination. So I'll multiply this bottom one by -3. So 5x1 plus 3x2 equals 15. -3x1 -3x2 equals -12. So what does that give me? 2x1 equals 3. 3 divided by 2 is 3/2 or 1.5. And then I got to plug that back in. So 1.5 plus what gives me 4? And that is 2.5. all of the intersection points come from the first two columns. So 0, 0, 0, 5, 0, 4, 3, 0, 4, 0, 1.5, 2.5. So algebraically, we have found all the intersections between all the lines that we had. However, some of them are not in the shaded region. Okay, the way you determine which ones are or are not in the shaded region is you cannot have any negatives anywhere in the row. So this second row here is a no. That point is not actually within my final shaded region. And this point down here is also not in the final shaded region because I ended up with a negative variable. Okay, I went too high and tried to compensate with a negative. I can't compensate with a negative when we're working with real world problems. So now I'm going to go back and graph these and show you where all of these points come from and show you for a fact that these are our 4 corner points. So if we go back and we graph these, let's see, 5, so I solve for, I'm going to make x1 here. This is x2. So if I solve for x1, that's 3, 1, 2, 3. It's going to cross there. And it's going to cross 1, 2, 3, 4, 5 up here at 5. So here's my first line. Second one, that's going to be 4 and 4. 1, 2, 3, 4. 1, 2, 3, 4. Like that. We also have the axes because they have to be greater than or equal to 0. This ends up being our final shaded region. So you should see the point 0, 0. You should see the corner point 3, 0. You should see this corner point 0, 4. And then this corner point here was the 1.5, 2.5. And those 2 additional points that we found, I'll mark them in red because they're not counted, 0, 5 and 4, 0. Those ones are outside of the shaded region, so we could not use them. These are the final 4 that we check. Okay, so algebra and graphing go together. They get us to the same answers. It's just there's a little bit of extra work involved because you have extra ones here that you're finding and then saying, oh, no, I can't use that. It's outside of the region. Okay. So then once we have our table done, all we have to then do is find our P. We know it's not going to be 0, 0. I want to get a maximum, right? Plugging in zeros is not going to give me my maximum. So we have 12x1 plus 10x2. So I'm just going to check those last 3 then. 0, 4, 3, 0, 1.5, 2.5. x1, x2p. So that's going to be what, 40? This one's going to be 36. 1.5. That's 18 plus 2.5, 25. And 18 and 25, is that 43? So there is our max. So again, I'm teaching you a way that if you ever came across that you did not have access to a graphing calculator, we could solve these by hand. I am going to also show you another method that goes back to matrices. So let's do another one. I am never going to go above 2 variables, 2 unknowns. Okay? It gets really, really long after that. So I will teach you this way so you guys understand the process. We want to maximize 80x1 plus 30x2. subject to the following inequalities. X1 plus X2 is less than or equal to 6. 3x1 plus x2 is less than or equal to 9. And x1 and x2 are both greater than or equal to 0. Okay, so again, we're not going to worry about the graphing part. The goal is, can we solve this by hand? So we have to convert our subject to inequalities to our equations. So x1 plus x2 plus my first slack is going to equal 6. And 3x1 plus x2 plus my second slack is going to equal 9. So I take those two inequalities, I make them equals to, but in order to make them equals to, I add the slack variable that's going to help me determine, is this a point within the shaded region or not? From there, I'm going to go to my table. So I'm going to rewrite my equations up at the top of my page here. So that was, what did I say, x1. All right. So we're going to pair our zeros. Two of the variables of the 4 have to be 0. So I'm going to do x1 and x2 already done. X1 and S1, X1, S2. All right, X1's been paired with everything. So X2 has already been paired with X1, X2 with S1, X2 with S2. Yeah. There are only 6 pairs of zeros that you can make. So I just go through, I'm pairing X1 with everything. So X1 with X2, X1 with S1, X1 with S2, sorry. No, I'm just putting 2 zeros in every row, but I'm pairing them. So like X1 with this one, X1 with this one, X1 with this one. Those are the 2 that are getting zeros in my problem. Okay, so I've done X1 to everything. So now X2 has to be paired with S1, X2 has to be paired with S2. So that's the next row, X1, S1, X2, S1, X2, S2. And then the last one is these 2. So it's the easiest way for me to find the pairs by starting with put X1 with everything, then take X2 with everything, and then take your last one, your S's together. All right, first one was already solved, really straightforward. You plug in 0 and 0, slack 6, slack 9. So second one, we have X1 is 0, S1 is 0. So I'm going to start with this first equation. So 0 plus X2 plus 0 equals 6. Makes X2 equal to 6. So then I go to the second equation. X1 is 0. So 0 plus 6 plus S2 equals 9. Slack 2 is 3. So that is going to be a good solution. Okay, I did not overextend here. Now, that automatically means, so when we graph these, right, and we have the origin, and we have these 2 lines that go like this, right? One of our corner points is on the y-axis, and one of them is on the x-axis, correct? So if this is the one, 0, 6, that's here, that's the one that is on our axis that is counted, then I automatically know this next one isn't going to work. It's going to be too far away or outside of the region because I can only have one corner point on that axis. So if I went and did this, you'll see that I'll get a negative when I get to my slack variable here. So let's see, 3 times 0 plus X2 plus 0 equals 9. So X2 is 9. And if I plug that back into the first equation, no, that's 0 plus 9 plus slack 1 equals 6. I was only supposed to make it to 6. And I wrote 9. I'm sorry. 6, this equation. So I've gone too high. In order to compensate, I'd have to negative. I can't use negative a product or negative whatever, labor hours. So this is too high. This gives me a negative. That's why this one doesn't work. Okay, So really what we're doing, this is the origin. We are then deciphering between which of the y-axis points is our corner. Now we're going to go here, which of the x-axis points is our corner. And then this is the intersection of the two lines, is always the last one. All right, so if we get some new colors here, x2 and s1 are 0. So I'm going to plug in that first one. x1 plus 0 is 6. So 6. Can I plug that into the second equation? 3 times 6 plus 0 is 9. No, I've gone over. Right? Oops, sorry, not 0. I am going too fast here. S2. I've gone too high. 18 plus slack 2 is 9. I've gone over too much by 9. So this point is not going to be the correct point. So I can just cross it off. I can write no. I know it's not going to be there. Okay, which means the next one is going to be our x-intercept point. So x2, s2, I'm going to use that second equation. So 3x1 plus 0 is 9. Divide, x1 is 3. But plug it back in here. 3 plus 0 plus slack 1 is 6. Yes. So I can make it if I add a slack of 3. So that is a good point. x1, x2, p. So far we 0, 0, I'm not going to check. 0, 6, 3, 0, and then I need my intersection of the two lines. So it's the system of equations. So I take my two initials. x1 plus x2 is 6. 3x1 plus x2 is 9. And if I subtract them, my x2s will cancel out. So x1 minus 3x1 negative 2x1, those are gone. 6 minus 9 is negative 3. And then when I divide, I get 1.5. And if I plug that back in, 1.5 plus what is 6? That's 4.5. So 1.5, 4.5. Now we have our 3 test points. That we can plug in. Let's see, that was 80x1, 30x2. So 30 times 6 is 180. 3 times 80 is 240. 1.5, that's gonna be what? 120 and 4, so 120 and another 15, 135. 255. And there is our mix. No, it's just the origin point. So the origin point is 0, 0, total. So it's kind of that one's, they give it to you because there's no math involved. It's just a quick, like, this is the origin. So 0, 0, what's left? I was short 6, I was short 9. Okay. Next point, 0, 6. I wasn't short anything here, but I'm short 3. It's okay to be short 3 because our goal is we're inequality. I wanted to be less than that, right? Versus when this one was a negative 3, I was over my amount. So that doesn't work. So I can't use it. All right. I'm going to actually, before I do that, let me talk one other little thing here. Just because I think it asks it in the homework. There's a term of what's a basic versus a non-basic answer. So when you're doing the homework, they're going to label them like row A, row B, row C, row D, row E, row F. And they'll say in row C, which are your basic variables, which are your non-basic. So basic variables are the ones that we solved for. So these are the ones we solved for. And the non-basic are the ones that are the zeros, the ones we canceled out for that row. So if I just look at row C, so row C, my zeros are x1 and s2. So zeros are at x1 and s2. So those are my non-basic. And the ones I solved for were x2 and s1. X2 and S1 are the ones I solved for, so they are my basic ones. It's just a term that it's going to ask you, like, can you pick out the ones you solved for in this row? So the other method to do this by hand is with matrices. So we're going to do that same thing of create slack variables. But now we're going to set the objective function equal to 0 so that we can create a matrix. We will find pivot columns and pivot rows so that we can perform to get our ones and zeros until we get all the way to the end to our final answer. All right, so we want to maximize 30x plus 40y. Here are our constraints. 2x plus 3y is less than or equal to 24. 4x plus 3y is less than or equal to 36. X and y are both greater than or equal to 0. So first step is to introduce our slack variables. So I'm going to take inequality 1, inequality 2. So 2x1 plus, 2x. I was used to the x1s on the previous problem. 2x plus 3y plus slack 1 is 24. 4x plus 3y plus slack 2 equals 36. And then we're also going to move these in our maximize function, move the x and the y back to the left-hand side. So it's going to be p minus 30x minus 40y equals 0. Okay, so that's the first step. Back there. Sorry, first and second step. So create equations with slack variables, set objective function equal to 0. So that's steps 1 and 2. Step 3 is to create our matrix. Our matrix is going to have the following: x, y, slack 1, slack 2, p, and then the answer. And I have 1, 2, 3 equations that I'm going to plug in here. So the first one is a 2 in front of the x, 3 in front of the y, a 1 in front of the s1. There is no s2, no p, and the answer is 24. Okay, second one, 4 for x, 3 for y, no s1, I have an s2, I do not have a p, and the answer is 36. Okay, this one is negative 30 in front of x, negative 40 in front of y, no s1, no s2, there is one p, answer of 0. I just moved, I need to get this set equal to 0. So I subtracted these over to the other side. So by bringing them over to the other side, then it's equal to 0. And then I can plug them in there. They're always going to be it's always going to be the opposite version of them in this bottom here. So take your x, make it the negative, take your y, make it the negative, p is 1, answer 0. All right, so step 4 is really easy, finding the pivot column. So the pivot column, you're looking for which of these two values in the bottom is the most negative. Well, negative 40 is more negative than negative 30. So that is step 4, our pivot column. Step 5 is find your pivot row. And the way you do that, you take your answer divided by the value you highlighted. I-L-I-G-H-T-E-D. Okay, so 24 divided by 3 is going to give me 8. 36 divided by 3 is going to give me 12. And according to the rule here, take the smallest. So this one is smaller. That means this is our pivot. We want that to turn into our 1. What we're doing, by doing this process, we're going to go through it 2 rounds to make X and Y, one of them 1, one of them 0, then in the other one, the opposite 1 and 0. The thing is, we don't know which one is the 1 and the 0 without doing this step here. This step helps us get to that final solution faster, okay? So for this first, we're going to solve for Y, all right? So we're going to use our row operations, and the goal is to get a 1 in the box. I don't want to circle that. That would be a step. So now we're on step 6. Step 6 is a lot because, you know, we got to do some work here. All right. The 3 in the box has to be a 1. So we use our row operations, and I'm going to divide row 1 by 3, and that's going to turn it into a 1. So I'm going to do that on the next slide if that is okay. Otherwise, I'm going to run out of room here. Okay, so I'm going to change the first row. It's going to be 2/3, 1, 1/3, 0, 0, 8. And then I'm going to carry everything else down. 0, 1, 0, 36, negative 30, negative 40, 0, 0, 1, 0. Okay, so I took row 1 and I divided by 3. Now you guys know that once we get the 1, we then have to get the zeros everywhere else in that column. So my goal in this is to keep the 2/3, keep the 1, keep the 1/3, 0, 0, 8. And I realize I'm going to need to make that a little longer here. And I want to make those zeros. That's my goal. So in order to do that, we take row 1 times the opposite of 3, and then I add it to row 2, and it's going to go back into row 2. And then I'll look at the same thing for row 3. So I'm going to take row 1 times the opposite of negative 40, so times by 40, and then add it to row 3, replace row 3. So I'm going to work piece by piece. 2/3 times negative 3 is going to leave me with negative 2. Negative 2 plus 4 is 2. All right, next one. 1/3 times negative 3 is negative 1. Negative 1 plus 0, negative 1. 0 times negative 3 is 0. 0 plus 1 is 1. Zeros are not going to change. 8 times negative 3 is negative 24. 36 minus 24 leaves me with 12. Okay, and then I'm going to repeat that whole process, multiplying the first row by 40. So that's 80 over 3. 80 over 3 minus 30 leaves me with negative 10/3. 1/3 times 40 is 40/3. I'm not adding anything, so 40/3. 2 zeros is going to stay 0. 0 times anything is 0, plus 1 is still 1. 8 times 40 is 320. 320 plus 0, 320. Okay. Our goal is working with this right here to be our 1001. So I know that the one diagonal from the 1 has to be my next 1. So my goal is to turn that into a 1. So if I take row 2 and I divide it by 2, it's going to change that into a 1. So 1, 0, -1, 1, 0, 12. Keep everything else the same. 8, 10 thirds, 0, 40 thirds, 0, 1, 3, 20. And then we're almost there. We have one more step, and that's to get the zeros here and here. Okay, so I'm not going to touch this middle row. I want to get a 0 there, a 0 there, and those are all going to stay the same. Because my goal is I want to get that identity matrix up here with the ones on the diagonal and the zeros everywhere else. So now we just have to figure out, well, how did we get there? Okay, well, I have 2 thirds. So I'm going to take row, oops, I'm going to write it up here. Row 2 times -2 thirds, add it to row 1. And the bottom one is row 2 times +10 thirds, add it to row 3. So let's see, row 2, got to go to this one. Shoot, this is a 1/2. I didn't divide everything through. What did I do? Oh my gosh. Hold on. Go back. I did not divide all of these by 2. -1/2, +1/2, 0, 6. I only divided the first number by 2. Everything has to divide by 2. My fault. Okay, so let's try that again. -1/2 times -2 thirds is a third. 1/3 plus 1/3, 2 thirds. Okay. 1/2 times -2 thirds is -1 third plus 0, -1 third. The zeros are going to stay. 6 times -2 thirds. So 6 divided by 3, 2 times -2 is -4, plus 8 is 4. Okay, middle row stays the same. -1/2, +1/2, 0. What in the world did I do? I added an extra spot in there. I said it was going to be fine. Now it's not fine. 0, 4. All right. Last row. -1/2 times 10 thirds is going to leave me with -5 thirds. Add 40 thirds is 35 thirds. 1/2 is going to leave me with 5 thirds plus 0 is 5 thirds. 0 plus anything is 0 plus 1 is 1. 6 times 10 thirds, 60 divided by 3 is 20. 20 plus 320 is 340. Now, our final answer is as follows. X, Y, P, answers. So 1, answer, Y is 4. 1, answer, X is 6. 1, answer, P is 340. A lot longer than solving it with graphing. But if you come across a problem that you're not allowed to, I don't know how it works when you take your finance tests, you have access to calculators on all of that, I'm giving you a fallback option, 2 choices. Okay, we'll do one more. And hopefully I won't make a mistake this time, even though I have the answers literally in front of me. All right, so we want to maximize 80x1 plus 30x2. 2x1 plus x2 is less than or equal to 6. 3x1 plus x2 is less than or equal to 9. x1 and x2 are greater than or equal to 0. All right, so we have x1 plus x2 equals 6. Nope. Slack 1 equals 6. 3x1 plus x2 plus slack 2 equals 9. And then I'm going to move these over. So P minus 80x1 minus 30x2 equals 0. So x1, x2, s1, s2, P, answer. So 1, 1, 1, no, no, 6. 3, 1, no, 1, no, 9. Negative 80, negative 30, no, no, 1, 0. So again, just putting the coefficients, and if it's a variable that's not in your equation, put a 0. So the first one doesn't have an S2 or a P, so it gets 0 in those slots. Okay, we then find the most negative column is that first column. So then we take our answer divided by the highlighted. So 6 divided by 1 is 6. 9 divided by 3 is 3, and we want the smaller one. So this spot here is the first one we're going to work with and turn it into a 1. So to get a 1, you multiply or divide your row. So we're going to divide by 3. So I'm going to take row 2 divided by 3. I'm not going to touch the other rows. So that was 1, 1, 1, 0, 0, 6. Negative 80, negative 30, 0, 0, 1, 0. All right, so dividing everything through, it was 3 divided by 1. Sorry, 3 divided by 3 is 1. 1 divided by 3 is 1/3. It was a 0, so that's going to stay a 0. 1 divided by 3 is 1/3. This one was a 0, so it'll stay 0. And 9 divided by 3 was 3. Okay. So we got our 1. Our goal is to get zeros here. So I want to get 0, 1, 0. And I don't want to touch the middle row. So the question is, how do I do that? Well, if I just subtract these two rows, row 1 minus row 2, I can put them in there. So 1 minus 1 is 0. 1 minus 1/3 is 2/3. 1 minus 0 is 1. 0 minus 1/3 is negative 1/3. 0 minus 0 is 0. 6 minus 3 is 3. Okay, but down here, I want to cancel out a negative 80. So I'm going to take row 2 times positive 80 and then add it to row 3. Because 1 times 80 is 80. 80 plus negative 80 is 0. So 1/3 times 80 is 80 over 3. Minus 30 is going to leave me with negative 10/3. Anything times 0 is 0 plus 0 is 0. 1/3 times 80 is 80 over 3. I'm not adding anything to it, so 80 over 3. 80 times 0 is 0 plus 1 is 1. 3 times 80 is 240. So next we have to find our next pivot. So we already worked with the first row, and it was a second variable that was our 1. So now it's going to be this guy up here. That's going to be our 1. So I'm going to keep row 2 and row 3 exactly as they are. That's 1/3. Negative 10/3, 0, 80/3, 1, and 240. Okay, so 2/3 has to turn into a 1, so I got to multiply by the reciprocal. So row 1 times 3/2. Anything times 0 is still 0. Reciprocal is going to make that 1. 1 times 3/2 is 3/2. Negative a third times 3 halves leaves me with a negative half. Anything times 0 is 0. And that's going to leave me with 9 halves. I'm going to try to show this in a different color. Okay, so now the top row is going to stay. Our first column is going to stay, and our second column is going to be zeros. So how do we do that? We got to multiply by the opposite. So this is a 1/3 here. So I'm going to take row 1 times a negative third, add it to row 2. 3 halves times negative a third, add nothing to it. Okay. It's negative a half plus 0, negative a half. Okay. Negative a half times negative a third, add a third. That makes 1/6 plus a third is a half. 0 and 0 is 0. 9 halves times negative 1/3, add it to 3. So negative 9/6 plus 3. That's negative 3 over 2 plus 3, negative 1.5 plus 3. So that leaves me with negative 1.5. Or no, positive 1.5. Positive 1.5 or 3 halves. There we go. Last row. Row 1 times the opposite, so 10/3, add it to row 2. Okay, 3 halves times 10/3, add 0. So 5 plus 0 is 5. Next column. Negative a half times 10/3. This one plus 80/3. We have 10 over 6 plus 80 over 3. Negative 5/3 plus 80/3, 75/3, 25. 0, 0 is going to be 0 plus 1 is 1. 9 halves times 10/3, add 240. 90 over 6 plus 240, 90 over 6, that's 15, 255. I do not put one of these on your exam. Okay? Okay, so final answer. 1, 9 halves. That's in the second spot. So x2 is 9 halves. x1, 3 halves. P is 255. And if you look, that's the first problem we did, which as the table. No, second problem we did? The second problem? Second problem we did, which the table was a lot faster than that. My preference, if I had to go by hand, is to do the table because I'm better with algebra. Clearly, these fractions and these row operations were a hot mess today. Even though literally when I made my answer key yesterday, didn't make a single mistake. Did the whole thing and I was like, oh, okay. Typed it in ChatGPT, checked it because I was like, double check my answer. And today I made like so many mistakes, it was ridiculous.